Hey guys, this is Mr. Gilbert. I'm coming to you with the first lecture on waves. Should be, again, stuff that you learned freshman year. Should be a review for you. It is Monday, and one thing that got added to our schedule for this week is that through your science classes, you have to do your scheduling for next year. There are some links right below this lecture for Monday. You have to get that scheduling done this week. That's really, really important. If you have questions, reach out to me, reach out to your teachers. If you want to know what classes you should be taking next year, don't hesitate to ask me or whatever teacher you have for that class. So, like, should I take the Accelerated English 4 or AP or regular? Don't hesitate to reach out to your English teachers or to me if you need any help with that kind of stuff. But you need to get your scheduling done this week. It's your requested schedule for next year. All right, and as always, I highly recommend you take science electives, of course, whether it be forensics or astronomy or oceanography or Kentucky animals and ecology. I just recommend you get out and take more science classes because I know they're fun, especially as you get into elective science, and it's stuff that you're really interested in. And that's where science really gets more fun, is when we're studying the stuff that we really, really like. So. Let's get into waves. There are guided notes posted as always. So what is a wave? Usually when we think of waves, we're thinking of the ocean, or we think of people who are going like this, so we think of the wave at the Reds game, right? And so, hey Colin Kidwell, please sit down and be quiet. Try to focus on the lecture here. So we think of waves in different capacities, but wave is defined as a repeating disturbance that transfers energy. A wave is a repeating disturbance that transfers energy. And specifically in parentheses in your notes, I would put not matter. Waves do not transfer matter. So while waves will often can temporarily move matter, that matter is not permanently moved. And so if you think of an ocean wave, many of you have been to the beach. If there's or even in the pool, you might have a ball or something sitting on the water, and a wave comes by and the ball goes up and the wave goes down, and then the water rests back where it was. The ball is back where it started. All right, the ball moves temporarily, but then eventually goes back to where it started. That's because waves move energy, not matter. Now, sometimes in situations like the ocean, that will not be totally true, but that's because there's currents and the wave is interacting with the shore, and there are other factors at play. The wave itself does not move matter. So there are two main types of waves. We have mechanical waves and electromagnetic waves. So we're going to focus on mechanical waves. So I really quickly want to define electromagnetic, and you'll see later in this unit there's a Bozeman YouTube lecture on electromagnetic waves. I'll let him teach most of that. We're going to focus on mechanical, but let me introduce electromagnetic real quick. Electromagnetic waves are waves not requiring a medium. So those are light waves is another word. So electromagnetic waves are also called light waves, and those do not require anything to go through. So that is everything on the electromagnetic spectrum, all the way from one end, which is infrared, all the way down to the other end, down to gamma rays and stuff, from radio waves all the way down to gamma rays, and so on. And that includes the visible light, the part we see. And one side of that's infrared, one side of that's ultraviolet. But none of those require medium, meaning they can pass through space. They do not have to have stuff to travel through. The other type of wave is a mechanical wave. So we have electromagnetic waves, and then you have mechanical waves. Mechanical waves, which is what we're going to focus on today, are waves that require a medium. And so what is a medium? A medium is matter through which waves travel. Matter through which waves travel. So that would be sound waves, for instance. That's an example. Sound waves have to have something to go through. So whether you're underwater in a pool and you can hear someone making noises, or you're standing in the air, there's some stuff for sound waves to travel through. Sound waves can't travel through space. There's no medium in space for them to travel through. So the medium is the stuff that the mechanical waves travel through. All right, so there are two types of mechanical waves. So there are two types of waves: electromagnetic and mechanical. And out of mechanical, there are two types of those. There are transverse waves and compressional waves. So transverse waves are how we normally picture a wave. So if you picture an ocean wave that's kind of going up and down, or even the way at a Reds game, the waves going up and down, all right? That's how we normally think of waves. That's transverse. Transverse wave is a wave which energy and matter move perpendicular to each other. A transverse wave is a wave which energy and matter move perpendicular to each other. So while the wave may be going this way, the matter is going this way. So one's going parallel to the ground and the other one's going up and down. So the ocean wave is moving into the coast, but the water is doing this. All right. Same thing with the wave. If we all do the wave, all right, it's going down the line of people, but the people are going up and down. All right, those are transverse waves. All right. The other type is a compressional wave. Now you'll also see this in textbooks and stuff, sometimes called a longitudinal wave. So compressional and longitudinal waves are the same thing. Those are waves in which energy and matter move parallel to one another. So that is they move the same direction. So the wave of energy is going the same direction. So an example is a sound wave. If you ever watch speakers bump in and out, they're pushing the same direction the sound is going. All right, so the energy is going this way, and the wave is also the material, the air, whatever is going this way as well. They're parallel to another. A good way to picture this is to picture a slinky. So if I lay a slinky down on a table and I pull part of it back and I let it go, and you can see that slinky going back and forth this way, the wave of energy is moving the same direction as the slinky itself. And so those are called compressional or longitudinal waves. Again, a good example of that is a sound wave. That is most often the example we'll hear. All right, so I think the next lecture that you're going to get to is on parts of waves. So I'll be drawing some waves on the screen and show you some examples of the different parts of waves. All right, make sure you get your scheduling stuff started today. Follow the guided notes for this lecture. And we'll get back to you in the next lecture. Let me know if you guys have questions. Thanks.